This video is going to be about torque, which we'll represent with the capital Greek letter gamma. Torque is a force acting about an axis, so it's going to cause rotational motion. We could also think of torque as the ability of a force to rotate a body. The more torque, the more the ability that force has to cause rotation. Torque is going to be measured in units of Newton meters. There's two ways of measuring torque. So if this is my axis for this egg-shaped body, and I apply a force vector from this point into this direction, I can find the torque by drawing a line of action through my force vector, and then drawing a line normal to my line of action to my axis, which we'll call d. The length of this line is d. So the torque acting on this egg-shaped body would be the force times d. It's more common to find the torque acting on our body by drawing a line from the axis through the point the force is acting from, and we'll call the distance between the axis and the point where the force acts r, and we'll call the angle between that line and the force theta. So we could say that the torque is equal to the force times that distance r times the sine of that angle theta. Now let's go through some examples of using this equation. Let's start out with the top example here, example A. The axis that it's operating from is the red circle with the x. The green arrow represents the force. In the first example, the force is acting at 90 degrees, and because the sine of 90 is 1, that'll be when the force of where the torque force is greatest. So we have torque is equal to the force times the distance to the axis times the sine of theta. The force that we're applying is 20 newtons, and it's acting 4 meters from the axis. The angle between the line drawn from the axis to the force and the direction the force is acting is 90 degrees, which makes our torque 80 newton meters. Now let's look at a force not acting at 90 degrees. So let's go to example B. We'll use the exact same equation as we used before. So our force is still 20 newtons, and our force is still acting 4 meters from the axis, but now our force is acting at 30 degrees. So since this is less than 90, we would expect this torque to be less. And we find that the torque is 40 newton meters in this situation. Now let's look at example C. In example C, the force is being applied along the axis, so straight out. So we'll still use the same equation. Our force is still 20 newtons, and it's still acting 4 meters from the axis. However, in this case, the sine of the angle is 0. And because the sine of 0 is also 0, that means in this situation there's going to be no torque. So in this situation, the torque wouldn't be, or there wouldn't be any force to rotate this lever. That's the end.